Hey everybody, I've had a couple of people ask some questions about exercise 3 from the WebAssign. And so I'm going to try and kill two birds with one stone. I'm going to try and help you out with that question, first of all. Specifically parts 2, 3, and 4. Those are the ones that I've received a couple of questions about. But then I'm also hoping that I can give you some strategies for how to solve especially ugly equations as we go forward this semester. So please remember that this is a calculus class, and so we expect that you know algebra, and so you're allowed to use numerical methods of solving. But the mathy part of me wants to show you the algebra first. So we are going to first talk about how do we solve for this algebraically. So part 2 asks how many times in the domain from 0 to 4 does this function equal 0.5? Well, I'm going to hopefully remind you of the period of a trig function, like a sine function. Normally the period is 2 pi, but there's a formula that you may have learned in the past where if you take your 2 pi and divide it by this number right here, pi, that is sometimes referred to as omega. But if you divide 2 pi by pi, you wind up with the period. So in this case, this function repeats itself every 2 units. So over the course of the 0 to 4 domain, it's going to repeat itself twice. And I gave you a little bit of a visual here. This is just one period of a sine function. And so if you remember from 0 to the top, that would be 2.1 in this case. It's going to hit 0.5 once somewhere over here and somewhere over here. And so we would expect that it's going to equal 0.54 times in an interval from 0 to 4. Unfortunately, it's not starting at 0 though because of this t minus 0.2. That's a shift to the right 0.2 units. So here's the algebra. So the first thing you should do is set the equation, the function that you were given, you should set it equal to 0.5. And then you would divide by 2.1. And then you would take the arc sine. Now, here's where things get a little bit tricky. So the arc sine of 5/21 is going to be the principal solution. But because sine is an odd function, there will also be a solution of negative arc sine of 5/21, but not at the same location on the unit circle. So this part's going to be kind of tricky, but we're going to add multiples of 2 pi. So k is just an integer in my solution here. So like if k was 0, this would just be the arc sine of 5/21. And if k was 1, this would be the arc sine of 5/21 plus 2 pi. And so you can just keep changing that value of k to different integer values and you'll get solutions. But those will only be the solutions on the left side of this little hill right here. And so the negative arc sine of 5/21, that'd be the solution on the right side of this hill. But those don't occur every multiple of 2 pi. They actually occur every odd multiple of 2 pi. So that's what this is all about. And this is definitely on the tricky side of trig. Okay. And so then the next thing you would do is you would divide both sides of your equation by pi. So you'll notice that there's a 1 over pi here, and then the pi canceled out. So now we just have a 2k. And then there's a 1 over pi here, and the pi canceled out on the 2k minus 1. And then we add 0.2 to get our solutions. So these expressions will give us solutions. And so now we can just start giving it different k values and we'll get solutions in that interval. So this left expression, I substituted k equals 0 and we get this. And so this is in fact one of the solutions. And if you plug in k equals 1, you'll get another solution. And then if you plug in k equals 1 and k equals 2 to this other equation, other expression, you'll get these two solutions, 1.12347 blah 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 and 3.123476961. That's accurate to 10 digits. And so you'll notice that these are the 4 numbers that we would get between 0 and 4. And so now your answer to part 3, they ask what's the first time in the domain, and that would be this number. Since they're asking for 3 decimal places of accuracy, you would type in 0.277 because that 5 is going to bump the 6 up to a 7. And then in part 4, they would ask what's the last time in the domain, and that would be this number over here, 3.123. That 4 causes you to leave the 3 right where it is. Now, I'm going to show you some different methods that you can use to solve. I'm going to give you a quick solution from Desmos first, and then I'm going to show you something in Geogebra. So in Desmos, the easiest way to do this is just to type in the function that you were given. And so I'm just typing that in. And I actually would prefer that we restrict it to the domain, which is 0 to 4. So here is the function that we're working with, and it's only graphed from 0 to 4. And then remember, we're trying to find out where it's equal to 0.5. So these intersection points right here, this is a quick way to get solutions. So there's your 0.277 that we saw a second ago. And there's 1.123 that we saw a second ago, and 2.277, and 3.123. Unfortunately, Desmos is set to give you 3 digits of accuracy, but if you were to zoom way in, it eventually bumps to 4 decimal place accuracy. So this is a quick and easy way to get some solutions out of Desmos. And you can do the same thing in Geogebra. So I don't know if you guys have experience with Geogebra, but you can start the graphing calculator and you can do the same thing. You can do y equals 2.1 sine of pi times, I'm going to use x. Geogebra tends to act a little bit better if you use x. But I'm going to do y equals that and 0.5, and then we're looking for the solutions between 0 and 4. So now I can do a command in Geogebra called intersect, F and G, and I can click right there. I'm actually going to use the intersect tool. Geogebra has these tools, these visual tools, and you can get those points now. So here's the 0.27652, so that should look familiar. And then if you wanted the last intersection in that interval, you would just do another intersect, and that would be right here. And so D is 3.123. So these are quick and easy ways to get those. Now let's say though that you would like a super accurate solution. And so Desmos cannot do this. So I'm going to teach you a quick skill here in Geogebra, and it's called the CAS calculator, which I believe is Computer Algebra System, I believe is what it stands for, CAS. And so here's how the CAS calculator works. You type in a command, solve, and what we're going to do is we're going to use this solve method that's going to have an equation and a variable and a list of assumptions. And so we're going to tell it the equation that we want to solve, which is 2.1 sine of pi times t minus 0.2. And then we're going to ask it to use the variable t, and then we're going to tell it where we want it to look for solutions, and that was only between 0 and 4. And something is wrong. Oh, I forgot to type. Forgot to type equals 0.5. We want to know where it equals 0.5. These ugly expressions should look familiar to you. They are simplified versions of that expression that I wrote in the slide a second ago. But these are the 4 numbers, and unfortunately you can't copy these out, so here's the trick you have to use. You can click here and duplicate the output, and then you can grab these numbers, copy, and paste them, and then Geogebra has this cool little button in the CAS calculator where it'll turn it into a decimal approximation. And then, like, if you wanted to know the 4th number, because that's what the question was in WebAssign, you could then type that in, do the same thing, ask it for an approximation, and there are your 2 solutions. And this is kind of nice because now you actually have expressions for those solutions. So if you're hanging up on the ugly algebra, hopefully this will help you out a little bit. One last thing, because unfortunately you cannot use these on any assessments in Math 170 because they're obviously connected to the internet. So most of you are going to be using a graphing calculator. And so I'm going to show you what this would look like on a graphing calculator. There's a way to solve. And the way the solver works, let me show you from the home screen here. So from the home screen, if you press your math button, before we say anything else, we should make sure that we're in radians. So hit your mode button, and sure enough, we're in radians here. And if you go to your math button and go all the way to the bottom of this first menu, there's a function called solver. Now, if you have a newer calculator, this might look a little bit prettier. I'm going to use an older one just so that we're all on the same page. But in the solver, you're going to type in an equation. And you can say I've already typed in 0.5 minus 2.1 sine of pi times x minus 0.2. You have to use x or type in your variable t later. So I just go ahead and use x. And then the other annoying thing about the older versions of this calculator is that you have to have it equal to 0. And of course, that's simple algebra. You would just subtract 0.5 from both sides. So 0 equals 0.5 minus 2.1 sine of pi times x minus 0.2 is the equation that we're going to solve. And then you're going to press the down arrow, and it's going to have this bounds. And that's where you're going to say, okay, I don't want to look everywhere. I only want to look between 0 and 4. And then here's where everybody gets confused about how this works. You have to give it a guess. So I'm just going to type in 0.1. And then you press alpha enter, which is your solver on a calculator. And it'll look for a solution. So there's the solution, 0.277 again. And then if you wanted to know a solution in the end, you would type in a number relatively close to the end, like I'm going to look for like 3.2, for instance. And again, you just type in, this is essentially your guess, and then you type in alpha enter, which is going to initiate the solve command, and it's going to find that other solution. And you can just keep looking for more solutions inside your bounds from 0 to 4. But this is a quick way to generate solutions using your graphing calculator. So I would really encourage you to learn how to use this tool. If you want, you can also just type in, just kind of like we did in Desmos a minute ago, but you can type in the equation that you're working with, and then type in 0.5, and then you can do a graph. I'm only going to look from 0. I'm hoping you all know how to use the window commands on a graphing calculator, but I'm only going to look there. And so we're only looking from 0 to 4, and then there's a command inside your calc menu that lets you look for intersections. So that's 5. And it's going to ask you for a first curve and a second curve because it needs to know which two curves you're looking for. And then you have to do a guess. And so you kind of just have to move your cursor close to where your solution is that you're looking for. So there's your 0.277. Yet again, we've seen that solution a million times now. And then if we want to know the other solution, we can just do the same thing. So here are these two curves. But this time I want to look at the fourth time in the interval. So I'm going to move my cursor over here and hit enter. And there's my 3.123. Okay, so there are a bunch of methods for solving algebra equations. And so hopefully this will help you get some solutions faster than doing things with algebra.